Okay, we're moving on to compound inequalities. I have two definitions I would like you to copy down. We'll be working with and situations. We will be working with or situations. So pause the video a moment and copy down each statement, and we'll discuss what they mean when we apply to math problems. Please pause the video. Thank you for pausing the video. We are going to work with two equations. We need solutions that will work in both equations sometimes, or we need solutions that will work in one or the other equation. This is going to be an and situation, so I need all the solutions that will work in equation number 1 and equation number 2. So equation number 1, I will graph. I will have open circle at 3, shade to the left because I need all numbers less than 3. Equation number 2, x is greater than or equal, so I'm going to do a closed circle. Then I need numbers greater than, so I would shade to the right. This being an and situation, I am looking for all the numbers that work here or here. So I'm going to randomly pick a number, and I'm just going to pick this. I'm going to say, let's let x equal -4. If I substitute that into equation number 1, -4 is less than 3, so that is true. If I substitute that into the second equation, -4, oh, it is not greater than 0, so this is false. This does not work in this equation and this equation. If I jump to this side of the number line and I say, let's let x equal 7, I put 7 into the first equation. 7 definitely is not less than 3. That is false. If I put it into the second equation, 7 is greater than 0, so that would be true. But we have and. I need to find numbers that work here, and they work here, so that does not work. When I jump to the center here between the closed and open circle, I'm just going to grab the digit 1. You could pick any number you want. If I let x equal 1 and I put it into the first equation, oh, that is true. 1 is less than 3. If I put it into the second equation, 1 is greater than 0. So it is true here and here. When it comes time to do your homework, all you would need to do is put a closed circle here, open circle, and shade in between, because every number in between will get me 2 true statements. Turn the page for me. Now I'm at the top of page 7. We're going to do the exact same thing again. I'm going to graph where x is greater than or equal to -4. So I will put a solid closed circle there, greater than to the right. I need x's that are less than 1, so I have open circle. Less than 1 would be to the left. We are looking for numbers that are true in this math problem and that math problem. So I will just grab a couple samples. I'm going to grab -7. I'm going to let x equal -7. -7 is greater than or equal to -4. That is false. I can stop right there. With and, it would have to work in both. It is true in the second equation though, but that doesn't matter because I need it to be true for both. If I wanted to test a +7, I'll say let x equal 7. 7 is greater than or equal to -4, so that is true. When I put 7 in for the second one, 7 is not less than 1, that's false. So these numbers will not work because and has to work for both equations. I'm just going to grab one here. I'll say let x equal -1. -1 is greater than or equal to -4. That is true. If I put -1 in here, it is less than 1. So on your homework, you would have a closed circle, open circle there, and just the numbers in between. You would not need to do any of the shading outside those parameters. Okay, we did 2 ands. We found numbers that work in equation 1 and equation 2. Now we're going to move to or situations. They need to have a solution that works in one or the other math problem. So I'm going to graph x is less than 4, so open circle there, shading to the left. Or x can be greater than 8, so open circle, shading to the right. To test this, I'll just grab some numbers. If I say let x equal -4, put it into the first equation. Oh, that is very true. If I put it into the second equation, oh, that's false. But it worked in one equation or the other, so that would stay shaded. That makes it work. So I'm going to really shade that thing up. Next, I'll just grab a number out here. I'm going to grab 10. I'll say let x equal 10. If I put 10 in here, oh dear, 10 is not less than 4. That is false. I will put 10 into the second equation. 10 is definitely greater than 8. That's true. So these numbers on this side work in one or the other equations. Just like I did last time, I'm going to grab a number from the center. You could pick 5, 5.5, 7. I'm just going to say let's let x equal 6. If I put in 6 to the first equation, oh, that is false. If I put 6 into the second equation, that is also false. These numbers between the two open circles do not work. I will not shade there. My answer would be all numbers less than 4 or all numbers greater than 8. I know I've only done 2 examples, but I would like you to pause the video and try the next 2 on your own. You can test the numbers if you would like. Shade really dark where you think the solutions will be. Pause the video, please. Thank you for pausing. These are the solutions I came up with. Because it only has to work in one or the other equation, all numbers less than -8 will work, and all numbers greater than 3 will work. Perfect. This was an and. I can only graph numbers that will work in this equation and that equation. To find those numbers, they are right in between -1 and 4.